So this next section is about computing work. Now in physics, work means something just a tad bit different than we understand work in our normal life. What work means is what happens when a force causes an object to move. So, if I am picking up a book, technically I am causing work to happen because I am causing the book to move. I'm applying a force and the book is moving. If I were to be pulling a wagon and I am unable to make it move, no work is occurring. Nothing is happening. No movement is happening, so there is no work. Work is also a scalar. It is not a vector. A scalar being a number. We compute work by taking the magnitude of the force times the distance traveled. The magnitude of the force times the distance traveled by an object. This is why if the object doesn't move at all, the distance is 0, no work is happening because you're multiplying by 0. So let's go ahead and try. How much work is done by lifting a 20-pound box 3 feet off of the ground? How would we compute work? You just multiply the magnitude of the force, which is 20, times the magnitude of the distance. So just the distance. And what do you get? 60 pound-feet is our work. Now, more often than not, work is normally having a unit of joules with a capital J, which is just multiplying newtons times meters. Anytime your problem has newtons times meters, you should write your answer as having a unit of J. So in example B, how much work is done if a force of 400 newtons is needed to move a box across the floor a distance of 10 meters? What would we do to find this work? Multiply 400 times 10 and get 4,000, and what is our unit? Joules. Okay, so in both of these examples, the force is going in the same direction as the movement. So notice, we're applying a force upward by lifting this box upward. And it's also traveling 3 feet directly upward. They're going in the exact same direction. That's why we can multiply the 20 times the 3. If the force is not going in the same direction as the movement, we have to add something to the end. So for example, right here, notice how this lady is applying a force upwards and to the left, whereas the movement of her suitcase is going directly to the right. All we have to do to compute work, instead of just multiplying the magnitude of the force times the distance, what you do is multiply the magnitude of the force times the distance times cosine of the angle between them. That was very sloppy writing on my part. So let's try. Suppose a child is pulling a wagon with a force of 50 pounds. How much work is done moving the wagon 300 feet if the handle makes an angle of 40 degrees with the ground? So our force that she's pulling is going upwards and to the right on an angle of 40 degrees, whereas the wagon is moving a distance of how much? 300, what was it? Feet. So all you have to do to compute this work is the magnitude of the force, which is 50, times the distance, times what? Cosine 40. So we do 50 times 300 times cosine of 40. Whoops. And we get 11,490.667 pound-feet of work is done. That's a lot of work. And we're done. That's it. Multiply the magnitude times the distance times cosine of the angle between them. You guys go ahead and do example or the on your own, and then we're done.